Good morning or good afternoon or good evening. This is Ms. Bauer here, and today we're going to talk about segments. Now, remember that a segment is different than a line because a segment has endpoints, whereas a line has arrows. So, a line has arrows, we can't measure it, but because a segment has endpoints, it means that we can measure it so we can do some math with it. So the number one thing to know about segments is that segment addition postulate says if you're given 2 points, A and C, if B lies between A and C, then AB plus BC equals AC. So let's go back and break that down. We're given 2 points, A and C. So if we sketch that out, 2 points, A and C, that next part is important. It says if B lies between A and C. Now, that word between means collinear. And if you remember from yesterday, collinear means that they're all on the same line. They're all going to be in the same segment in a row. So if I connect A and C, B is just going to be between them. And when we say between them, we don't mean up here or down there between. We mean somewhere on there between. It doesn't really matter where you put it. For now, I'm going to put it a little to the left. There's point B. Now, it says if B lies between A and C, then AB plus BC should equal AC. So, let's say that A to B is 7. I'm just making these numbers up off the top of my head. So, if I say that from A to B is 7, and then let's say that B to C is making up another number. Let's go with 43. So, this piece to this piece from B to C is 43. Well, the green plus the blue should equal the whole thing. So if I ask you to find the distance from A to C, well, look at those parts that we have. So 7 plus 43 would make the full distance from A to C 50. And the easy way to remember segment addition postulate is to remember that a part plus the part equaled the whole thing, 50. That part 7 plus the part 43 equaled the whole 50. So for short, I'm going to write P plus P equals W. But just remember that means part plus part equals whole. And that allows us to solve all sorts of problems with segments in geometry. Another important thing to know about segments is that if they're congruent, they should have the same shape and same size. And we'll put something on our picture to note that they're congruent. So if they're congruent, maybe you remember this from the other day, maybe not. If the segments are congruent, we'll put ticks on them to show that they have the same measure. Now, what that means is if one is 5, the other one is 5. If one is 6, the other one is 6. If one is 2,304, the other one should be 2,304. We know that because of this symbol right there, that tick. Now, let's say that you went ahead and you named these. So I'm going to keep it simple. We're going to call one segment AB, and we're going to call the other segment CD. A way that I could actually write this out with geometry notation is I'm going to say that AB, the segment, is congruent, and my congruent symbol is just an equal sign with a squiggle on top. So AB is congruent to CD. And as soon as we see this symbol, the equal sign with the squiggle on top, or we see ticks, that tells us that whatever one is, we know the other one. So if this is X and this is 7, X would equal 7. Pretty much one part equals another part. This piece equals this piece. So instead of P plus P, I'm going to say P equals P because a part equals a part. Now the midpoint is just what it sounds like. It's the point that's in the middle of a segment. So instead of having two different segments that happen to be congruent, we could have one big segment that we cut in half. So I'm going to go ahead and draw segment AB again. Make it a little bit longer this time. And then I'm going to put this point right here, M, and put ticks on either side. Remember that those ticks mean congruent, meaning that if this side is 10, then the other side would be 10, which makes M our midpoint in the middle. Those ticks are important in the picture because they show us that M's in the middle. Now, midpoint helps us out. If we know that M is the midpoint and I have the whole piece is 50, think about it. If the whole piece is 50, how many should be on each side if M's in the middle? Well, I should have 25 and 25. Middle, just cut it in half. If we know that the whole piece is 70, cut it in half. 35 and 35. It goes the opposite way as well. If I know that this side is 10, the other side is 10, and then the whole thing would be 20. So with a midpoint, I just know that it's still like congruent. A part equals a part, a tick equals a tick. Now, sometimes our pictures will have more than just a point and ticks as a midpoint. Sometimes we'll have a bisector. And the easy way to remember a bisector is that it's the thing that cuts something else in half. So, for example, M's our midpoint, but what if it had this line going through it like that? And I know that it's a line because I put arrows on the edges. Well, this green line would be the bisector. The point where it's cut in half would be the midpoint. So this piece right here, that line, and it could be a line array or another segment, but lines are really common. That's your bisector. The actual point, so the bisector cuts it in half, the actual point, that's your midpoint. So if it's a bisector, do you think that would be a part plus part equals whole problem, or would that be a part equals part problem? Use a picture to help you out. And if you said part equals part, you're correct. The bisector cuts it in half. It makes two equal parts. It has a midpoint in there once you get the bisector, and it works out. Okay, now let's look at a picture. The first problem says use segment addition postulate to find xz. And if we notice, there's no symbol on top of xz, which means the distance or the length. So what this problem is asking you to do is just find what's the distance, what's the length from x to z. So segment addition postulate. That piece plus the other piece, one part plus one part should equal the whole. So what's 23 plus 50? 73. That's how we get our answer. So I can just say xz equals 73. Remember, when I don't put the segment symbol on top, that means that I'm talking about distance or length. Okay, now in this diagram, if we know that w to y is 30, so if we know that this piece is 30, could you use the segment addition postulate to find the distance between the points from w and z? So think about it. Yes or no? If we know from w to y and we know from y to z, could we use segment addition postulate to find the distance between points w and z? It's either yes or no. Now, if you said no, you're correct, because this word between means collinear. Don't forget, from up above, between means collinear. So if we're talking about points w, y, and z, they must be collinear in order for me to use segment addition postulate. So what's the distance from w to z? Well, I have no idea because y is not between it. Therefore, I cannot use segment addition postulate. And it says explain. Now we have several explanations. We could say no, because y is not between w and z. Or I'm going to say no, the points are not collinear. But there's more than one way for you to say that. Now, taking a look at this one right here, it gives us the diagram, and it wants us to find this distance from w to x, finding this piece. Use a calculator if you need to and see if you can get it. And if you got 107, you're correct. Now, how did we get that? Well, we didn't add in this case. Sometimes we don't do part plus part equals whole. Sometimes we just ask ourselves, do we have the whole and what's missing? And in this problem we did. So we had the whole, 144. If I take away the piece that we know, 37, well, what's missing? 107. That's it. Now let's get into some solving. In this next one, it says identify the midpoint and bisector of PQ and then find PQ. If you see an X in geometry, one of your first steps is probably going to be to solve for X. But before we get there, let's tackle the first half of this problem. Identify the midpoint and the bisector. So take a look at your picture. Which one is the midpoint? And if you said point M, you're correct. Well, what would be the bisector? What was the thing that did the cutting in half? If you said line L, you're correct. And now it's time to find PQ, but first I have to solve for X. Now, these ticks are a big clue to us, and we have that word midpoint and we have that word bisector. Remember that the ticks mean that those parts, that those pieces are exactly the same. And if we go back and we look at our notes, midpoint and bisector and congruent were all P equals P or part equals part problems. And now that I know that vocabulary and now that I have that clue that it's part equals part, I can easily solve for X. So I'm going to take each part and set them equal to each other. That's geometry helping me set it up. They're congruent, midpoint, bisector, all those clues tell me that 5x minus 7 equals 14 minus 2x. And I like to say LOL often, not laugh out loud, but in algebra, letter on the left. And for this particular problem, we start on the right and then we're going to put the letter on the left. So instead of subtracting 2x, I would do the opposite. I'm going to add 2x to both sides. 5x and 2x makes 7x minus 7 equals 14. I'm trying to get x by itself, add 7 to both sides. 7x equals 21. Divide both sides by 7, which makes x 3. But if we go back and look at that problem, it didn't want x. It wanted the distance from P to Q. So how would I find that? And if you said plug it in, you're correct. We're just going to go back and we're going to plug in 3 to both parts. So I need to figure out what's 5 times 3 minus 7 and what's 14 minus 2 times 3. If 5 times 3 is 15 minus 7, makes that side 8. And 14 minus 2 times 3 is 8. Well, we did it right. The ticks meant that if one side was 8, the other side should be 8. So what's the distance from P to Q? 8 and 8 makes the distance from P to Q 16. And that's it. Now, sometimes they don't give you a picture, which means now we're going to have to draw one. We're going to have to make one on our own. Pictures and diagrams are so important in geometry. So taking a look, this first sentence is all that we need to get our picture. T is between S and U. So that means that we're going to draw a segment. And if T is between S and U, think about it. What should go on the ends? If you said S and U, you're correct. I'm going to put T between. It doesn't matter. In this case, I'm going to put it farther to the right side. And now I'm going to read my information. From S to T is x minus 6. So from S to T is x minus 6. From S to U, so that's the whole piece, from S to U is 10. And then from T to U is 2x minus 8. Well, I tried to give you a clue and emphasize it, and it kind of gave you a clue in the problem. If it gives you the whole, it's a clue, it's a hint that you're going to add the parts together to equal the whole. So this wouldn't be a part equals part problem. This would be, back up, that segment addition postulate. This would be a part plus part equals whole problem. And a clue is that they gave you the whole. If they tell you what the whole is, there's your clue. So part plus part, if we go over and we look at our parts, x minus 6 and 2x minus 8, Part plus part means that I can just go ahead and combine like terms. I'm going to do part plus part, add them together. So combining my like terms and the parts, what's x and 2x make? 3x. Then what's negative 6 minus 8? Negative 14 equals our whole was 10. And then from there, I'm just solving. So add 14 to both sides. So 3x would equal 24. Divide both sides by 3, which makes x 8. Now I need to be careful because did the question ask for x? No, it wanted the length from s to t. So I'm going to go plug it in and find out, well, what is 8 minus 6? So st equals 2. And a way to check it is that if this piece is 2, well, then the other piece should be 8. So what's 2 times 8? 16 minus 8 is 8. It works out. We did it right. For our last problem, they don't give us a picture either, but once again, we have everything that we need to draw our diagram from that very first sentence. If C is the midpoint of A, B. So I'm going to go ahead and sketch this out. Today is all about segments, so I know I'm going to draw a segment. And the clue that they give you is that C is the midpoint. So C needs to go in the middle. Now, this picture isn't quite done because remember that if it's a midpoint, those parts are equal. Therefore, I should have some ticks on my picture. Don't forget that. Those ticks in the picture tell us everything. So a tick and a tick. Now I'm going to read and label. A to C is 8x minus 8. And A to B is 14x minus 12. Find C to B. Now, the word midpoint meant part equals part, but if I try to put these parts together, I'm going to have a problem because this is a part and this is a whole. So I need to think about this problem before I set it up. Now, think back to what the ticks meant. So if this piece is 8x minus 8, think about it. If this piece also has a tick, what should it be? And if you said 8x minus 8, you're right. And now I'm going to use that to do part plus part equals whole. So I had two 8x minus 8s. And when I combine like terms, or if you multiply by 2, either way, we're going to get 16x minus 16 equals our whole, which was 14x minus 12. From here, we're going to LOL, put that letter on the left by starting on the right, subtract 14x. 16x minus 14x would make that 2x minus 16 equals negative 12. Add 16 to both sides. So 2x would equal 4. Divide by 2, x would equal 2. These algebra skills are super important in geometry because if you can't solve for x, you're going to have trouble in the problem. Now, we might think that we're done, but it's super important. Go back and read. It didn't want x, it wanted CB. So go plug it in. What's 8 times 2 minus 8? Well, 8 times 2 is 16. What's 16 minus 8? 8. And you could plug it into the other values to see if it works, and it does. So CB equals 8. Hopefully today you learned some stuff about segments. Don't forget that you can always rewatch this video, pause, slow down if you have questions on anything. Good luck with your practice.